Thank you very much. Thank you also for the kind invitation to present today. I'm very happy to be here in Dublin. Let me see how this works. I think it's just going to be the next one. So I have no conflicts of interest to declare. I cannot see the screen here. Maybe that can be changed.
No, it's
just there. Okay, great. So I'm going to start with some introduction into iron homeostasis and why actually iron is such a big topic in donor health. Iron is being circulated, of course, in red cells in your bloodstream, which is, of course, the important thing to donate. And red cells, after being circulated for some while, they are phagocytosed by macrophages, and the iron in the hemoglobin in the red cells is being reused for the renewal of making new red blood cells in the bone marrow. So that's actually a circulating amount of iron. There's of course also iron in the plasma that's also being used for erythropoiesis. And there's iron stored in the liver, which can be used in case of low levels of iron or higher demands of iron for erythropoiesis and other processes in the body. Apart from that, there's also, of course, iron that you take up from your diet every day. So approximately 1 to 2 milligrams per day of iron is being uptaken in your duodenum, in your bowels. And about 1 to 2 milligrams per day is also lost, mainly with sweating and also the shedding of cells. But then with a blood donation, you suddenly lose an amount of approximately 250 milligrams of iron, which is of course much more than the 1 to 2 milligrams that you use on a daily basis normally. And as a result of this, of course, your demands for iron, they go up, and that causes your hepcidin levels to be downregulated, which then increases the amount of iron that's being freed from your stores, so that it can be used for increased erythropoiesis. And also the iron that is taken up from your diet in your duodenum is also being upregulated by the downregulation of hepcidin. So you actually take up more iron from your food after a donation, which then helps, of course, to replenish those iron levels after a single donation. But of course, if you can, as you can see here, it can be upregulated to about 3 to 4 milligrams per day that you take up from your food. But that still takes, in an ideal situation, about 2 months to replenish the amount that you lose with one donation. And we know that in practice, actually, this takes much longer even. So most blood banks, of course, measure hemoglobin levels, which basically measures, of course, the amount of iron that you have circulating in your red cells. And then increasingly, ferritin levels are also being measured to get an idea of the amount of iron that is stored in your body. And then this figure from Joseph Kiss and others, also Ralph Vizzello, shows the amount of iron relative to that is lost with one donation, all the way to the right, relative to the total iron stores in a human body. And as you can see, for young women, it's one donation is on average more than half of the total amount of iron that is stored in the body. And even for male donors, it's about 1/3 to 1/4 of their total body iron stores that is being lost with one donation. So that's quite a lot. And we've been doing a study at Sanquin a couple of years ago, following up after one single donation to see what happened to levels of hemoglobin and also to iron-related parameters. And as you can see, all the way to the left is the time point of the donation, and then we're followed up with additional small blood draws to measure these markers again. And hemoglobin levels are actually more or less back to the original situation after 56 days, indicated with a red line here. But the ferritin levels on the right side, they actually after 56 days are at the lowest point, and after that they start to increase again. But it takes at least, so the study was followed up for 6 months after one single donation, and even after 6 months the majority was not back at their original ferritin levels, indicating that of course with repeated blood donations your ferritin levels will go down even while your hemoglobin levels will stay leveled. And this is indeed what we've shown when Sanquin had just started measuring ferritin levels in donors. This is a study performed by a PhD student in our department, Marieke Vinkenhoog, who just simply analyzed the ferritin levels of new donors compared to the repeat donors. And as you can see in the dashed lines, the repeat donors, they really show this shift to the left of much lower ferritin levels in comparison to the new donors. And even the difference, the original difference between male and female donors seems to vanish in donors that repeatedly donated. So they all shift towards a level of iron deficiency. And of course, because of that, well, there's many studies that are being done or have been done related to the subject to find out which is the optimal way of handling this problem of iron deficiency in donors and being able to protect them from becoming iron deficient and of course also as a potential result anemic. But there's still a lot of debate and discussion, of course, to what the ideal policy basically is. So in the BEST Collaborative Donor Studies team, where I'm a scientific member, we have collected data from 38 blood establishments all across the world who provided data on the type of policies that they had implemented and also on their hemoglobin deferral rates. And we analyzed all those policy elements together in relation to the deferral rates, which actually showed that the minimum donation intervals were significantly associated. So the longer they are, the lower the hemoglobin deferral rates in that specific blood establishment. Asian blood services showed really high deferral rates in general. Probably also has to do with smaller body size and the relative bigger amount of iron and blood that is lost with one donation. And then a post-donation measurement policy, but also iron supplementation are related to somewhat protective effect against hemoglobin deferrals. So we concluded from this study that variations in hemoglobin measurement and eligibility criteria across blood donation services are associated with differing low hemoglobin deferral rates. And of course we have been comparing different situations, so it's a bit like comparing apples and oranges maybe, but it is of course these findings that that I just showed you are also been shown in randomized controlled trials such as the interval study, which has shown that actually the other way around, that shorter minimum donation intervals are significantly associated with lower hemoglobin and lower ferritin levels. And the trial by Joseph Kiss that was published in 2015 also showed that iron supplementation, mainly in females but also in male donors, was really helpful to increase the replenishment of iron levels and also hemoglobin levels in donors after a donation. So what are we currently doing in the Netherlands at Sanquin as a policy? So our blood bank measures hemoglobin levels with a HemoQ in capillary blood before every donation. And these levels must be higher than 13.5 grams per deciliter in men or 12.6 in women. And in addition, in 2017, there's been a new policy implemented to also measure ferritin levels. And these ferritin levels are not measured every donation, but only every 5th donation. And they're measured after the donation because the samples have to be taken to a lab to measure these levels. And then if the levels are too low, so they actually have donated then already, then they cannot make a subsequent donation for 12 months if they really are iron deficient. So if their levels are below 15 nanograms per milliliter. And they are deferred if they are at risk of becoming iron deficient, or perhaps even if they already have iron deficiency at that point, because of course they have donated after taking the sample. In that case, they're deferred for 6 months, and if the levels are appropriate, so 30 nanograms per milliliter or higher, then there's no deferral at all, and they can just simply donate again after 3 months. So when we just started implementing this policy in 2020, you could see that the deferral rates were very high. So the donors that were measured, in 20% of the female donors, we saw ferritin levels that showed a level of iron deficiency, and also in 11% of the male donors. And actually this resulted in having to defer 40% of the male donors and even 60% of the female donors that had their ferritin tested. And of course, luckily, it's been measured only every 5th donation, so that results in general a bit lower deferral rates than what you see here, but still it's quite shocking, of course, to know that there's this many donors that cannot donate for a very long time. Then we did a study that was funded by the European Blood Alliance a few years ago, the FIND+ study, where we measured repeatedly measured ferritin levels in donors that started as a new donor, and we followed them up over 2 years and measured in archived samples from their donation, measured their ferritin levels at every single donation they made, to see what happens longitudinally with these ferritin levels, and if we could indeed confirm that ferritin levels go down in donors, and also see if there are perhaps some subgroups of donors that do not show this decline, because of course that might also be related to some kind of genetic difference that might be beneficial for donors. So as you can see in these spaghetti plots, you do see that the tendency to decline is very obvious. And using cluster analysis, we actually got into 2 groups that were ideally clustered in terms of their trajectory in ferritin levels. And as you can see, there's both in men and in women a group that declines fast and a group that's pretty stable, but the difference between the groups is basically their starting point. So the higher their initial ferritin levels are, or the larger their iron stores, the more room, of course, there is to decline, and that's also what happens then. So it's probably because of the hepcidin response that's only being triggered when the iron stores are really low, that the decline doesn't go as fast anymore as in the donors with high ferritin levels initially. These are results then from our donor insight study, where we cross-sectionally measured ferritin levels in donors and also other parameters. And this was a study that had been done before the implementation of the ferritin measurement policy in the Netherlands. As you can see on the left side, hemoglobin levels were not associated actually with the numbers of donations on the x-axis that the donor made. So despite the really high numbers of some of the donations that some of the donors made, their hemoglobin levels stayed pretty similar, which probably has to do with the fact that, of course, the hemoglobin levels are measured prior to every donation, which causes a selection effect, of course, of donors with low levels or declining levels out of the donor population. But at the same time, we saw that ferritin levels do show a very significant decline over increased numbers of donations. And in addition, we also analyzed whether iron deficiency in the donors that participated in donor insight at that point was associated with hemoglobin deferral in their subsequent donation. And again, these donors were not deferred from donating because we only measured their ferritin years after they actually made this donation. And we saw very, very high odds ratios for being deferred for low hemoglobin levels in donors that were iron deficient at the previous one. So the relative risk, so to say, was 10 to 22-fold higher for donors that were iron deficient in comparison to non-iron deficient donors. This here shows actually what happened after this ferritin measurement policy was implemented. So these are the first results that actually came directly from our blood bank. So like I said, it has been implemented in 2017 and 2019 very gradually, also to decrease the impact on the availability of blood. And on the practice in the blood bank sites. As you can see over the years that it has been implemented, you see, of course, an increase in the numbers of donors that were deferred because of low ferritin levels, and this went up to approximately 11.5%, but that, of course, is only in comparison to the total amount of donations that were being made, so that's why it's lower than what I've shown you before. But at the same time, we also see that the hemoglobin deferral rates go down, which probably is a result, of course, of this policy. And it's also a quite significant decrease. But of course, we wanted to properly evaluate the effects of this new policy. So before it had been implemented, we from the research division actually collaborated with the blood bank to find a way to implement this policy without delays, while still being able to actually evaluate the effects of this. And for that, we set up the FIND'em study, which is a stepwise cluster randomized trial. And this actually meant that all the clusters of blood donation centers across the entire country were randomized prior to the implementation of the policy. And then they implemented this new policy in these different clusters step by step. So they started in November 2017 with implementation in 8 different clusters across the Netherlands, and then subsequently in May 2018 another set of clusters implemented the policy until the entire country had the ferritin measurement policy up and going. And we did some measurements rounds just before the start of implementation, also midway through implementation and at the end of the implementation, to measure ferritin levels also in donors that were not exposed to the policy. But we did that, of course, way after their donation, so without the effects of deferral then. And we also asked all donors that came to a donation site during one single week to complete questionnaires about their health, how they felt, also, of course, iron deficiency related symptoms that they might experience, like restless leg syndrome, fatigue, also pica in the cognitive functioning. And we also analyzed the donor return to see if the policy has some effect on donors' willingness to keep on donating. This is a very large table with the results. This actually shows from left to right how long after implementation of the policy you can see which effects on ferritin levels for the different subgroups of donors. So we divided the results for premenopausal females, postmenopausal females, and men. And as you can see, the longer the policy was implemented, the more significant the increase in ferritin levels was. And also we saw much lower levels of iron deficiency in donors, and hemoglobin levels also significantly went up, as well as the decrease in hemoglobin deferral rates. And we did not really see an effect on donor return, but there was some tendency towards less returning donors, also depending on how actually we defined that criteria. So the donors were a bit less likely to return to donate in the centers where the policy had been implemented, which of course might also be, is probably due to the fact that many of them had been deferred for a really long time. And this actually shows for the separate weeks where we measured ferritin, and we actually added another week because we saw that the longer that the effect of the policy really took a long time. So we measured prior to the implementation, week 0 is that quite high levels of low hemoglobin deferral rates. So between 4 and 6% of the donors were deferred for low hemoglobin at that point. Like I said before, approximately 30% of the donors were iron deficient, and approximately 50% of them or even more showed a bit lower ferritin levels, so 30 nanograms per milliliter or lower. And if you then look to week 1, mid-implementation, week 2 at the end of implementation, and then week 3, 1 year later, you clearly see that all the rates actually go down very significantly, and we end up with iron deficiency levels of approximately 10 to 15%, and low hemoglobin deferral rates of 2 to 3%, which is much less, of course, than before the policy was implemented. So I think that's a very comforting and promising result. But then the results from the questionnaires on donor health were not that, well, not that promising, I must say. We saw actually no effects in pica or fatigue, also no effects on cognitive functioning, no effects also on physical and mental health. And we saw some increase, very surprisingly, in restless leg syndrome. And we are wondering whether that might have something to do with the way it's been communicated, the new policy. So maybe there has been some communication about restless leg syndrome as a potential symptom of iron deficiency that might have caused donors to report that more often in the centers where it had been implemented. But we simply do not know that, in fact. So that's a surprising result, and for the other symptoms, unfortunately, we don't see any differences, even though the ferritin and hemoglobin levels, of course, have very significantly increased. So that's somewhat disappointing, of course. Then also because of the big impact, of course, of the long-term deferrals, we have started about 1.5 years ago the Forte study, which is an iron supplementation study, a randomized controlled trial to assess the efficacy of iron supplementation at different dosages and also frequencies in our donor population, to be able to investigate whether that might be an alternative, of course, to the long-term deferrals after the measurement of low ferritin levels. So for this trial, we're including 1,200 donors into the trial, all of them with low ferritin levels. So the donors that actually have levels that at this point leads to a deferral for 6 or 12 months. And they are randomized to either daily or alternate daily supplementation of either low dose iron levels, 30 milligrams, higher dose is still quite low, 60 milligrams, or a placebo, and then they're asked to take that for 30 days, if I'm not mistaken, and then we follow them up after that. And as a side project, we're also interested in finding out what donors actually think regarding these iron supplements, because this has never been tested as a policy in the Netherlands, and there's a lot of insecurity actually about the perception of donors towards taking these supplements, and whether they would be willing to or would rather eat more iron to be able to replenish their iron stores. So we've been doing some focus groups on that, and we're also setting up a survey to assess these donor perceptions and also their amount of knowledge regarding iron depletion due to donation. So the study design, like I said, 1,200 donors are being included, 600 females and 600 males, and then they're randomized to these 6 subgroups with different frequencies and dosages. And then we start by inviting them approximately 3 weeks before they're eligible to donate again, in principle. And they will also receive a questionnaire at that point to complete. So just before they come in to donate, they already complete questionnaires about their health status and also dietary intake of iron. Then when they come in to donate, they can sign their informed consent, make the actual donation where also the ferritin level is measured. And if the ferritin levels are then below 30 nanograms per milliliter, they are randomized into the study, after which they're followed up after 56 days, so after the supplementation period, with another small blood sample, also follow-up questionnaires, and then that's repeated after 122 days and again after 6 months to see what the effects of the supplementation is for the different subgroups. So what are we measuring? We're measuring ferritin levels, we're doing a full blood count, and with the questionnaires we're assessing their general health, physical activity, menstrual status as well, because of course that has a big effect on iron levels as well. We're also asking them about any gastrointestinal complaints, because of course that is a very common side effect of iron supplementation. Iron deficiency related symptoms, and also their intention to donate. And we're storing also some samples. And then at baseline, like I said, the food frequency questionnaire, which is specifically tailored to also assess the amount of heme and non-heme iron that's being taken by these donors or being eaten. And we're isolating DNA also to be able to see if there's genetic differences in the ability to take up the iron that's being supplemented. Of course, it's very important to be sure that when you provide them with iron supplements that they actually take them. So we're also very focused on treatment adherence measurements. So we're asking them when they return to the blood bank for their follow-up measurements to also take their leftover supplements so that they can actually be counted by the staff at the collection center. But we're also asking them about their compliance in the questionnaire, and all the donors that participate in the trial are asked to install an app which is called MedApp, which is actually an already existing app to remind people to take their medication. And we use that to remind them to take their supplement, and they can also enter into the app whether or not they've actually taken it and at what time point. So with that we will receive very detailed information of their treatment adherence. So the focus groups that we've done, we've been interviewing donors in groups, so groups with new donors, repeat donors, and we also interviewed donation staff, so donor collection staff, to see what their opinions are about iron supplementation in donors. And for donors, the main motivators to supplement with iron, if they would be willing, would be to prevent deferral due to iron deficiency, is what they self-reported, and also to reduce any iron deficiency symptoms if they would come up. But of course also some barriers were mentioned, and this was mainly being afraid of any gastrointestinal side effects, but also just objecting against dietary supplement uses in general. And then additionally, the donors expected if it would be implemented as a blood bank policy, that there would also be extended guidance from the blood bank and mainly from the donor physicians with extra checkups to see if it really helps to increase their ferritin levels, and also active involvement of donor physicians. So that's something to take into account. Let me go back. And we're actually now doing a follow-up on this with a questionnaire to see if we can get more quantitative data on how many donors would be willing or would not be willing to take iron supplements, and also what their motivators and barriers are, and what their levels of knowledge about these iron deficiency related to blood donation is, and also how they feel about being deferred from donating for a long time. And this is actually a questionnaire that we're also asking other blood services to send out, and I think there's about 10 blood services that now have agreed to participate, so they will share with us their policies and then also ask their donors to complete this questionnaire so that we can get an idea of internationally in relation to the existing policies there, what donors feel about iron supplementation and other iron management policies in general, so that we can take that into account when designing what ultimately the ideal policy could be. Then as a follow-up, we're currently working on setting up a biobank at Sanquin, which is also going to be used, of course, for donor iron management studies. This biobank is called Sanquin Future Health, and we are currently aiming for the inclusion of 15,000 donors. We're actually running a small pilot at the moment, so this week we'll have about 150 or 200 donors participating to see if all the processes actually work as they should. And we're collecting data from them, a questionnaire, and of course also samples. And we're planning on doing that approximately twice a year. When they come in to donate, there will be a trigger in the donation system that additional samples need to be taken from their sampling bag that can be then processed and stored into our blood bank. And at the moment, we're currently focusing on collecting and storing plasma and serum and DNA. And of course, we might extend both the amount of donors to include, as well as the measurements that we are planning on doing in the future. So from the donor's perspective, the participation in this biobank is actually means that they will be invited by email, so they will not be prompted when they walk into the donation site, but they can actually read through all the information at home. But then when they come in to donate, they're asked to sign the informed consent, and also then the samples will be taken and processed to store at -80 degrees, and then they will receive an online questionnaire to complete at home. We just heard from Christian that the response rates are very high if they can do it on site, of course, but we actually want to do a bit more extensive questionnaires, so we hope with reminders that they're actually also going to complete them if they can do it at home. And then this process will repeat itself, of course, every 6 months. And the purpose of the biobank, actually quite similar to the Danish blood donor study, is to investigate different kinds of outcomes and events. So, of course, we're mainly interested ourselves in anemia and iron deficiency and other donation-related outcomes, but we're also planning on doing studies on cardiovascular disease, potentially also on cancer, infectious diseases, and diabetes and inflammation. And the idea is, of course, to when you follow up a group of people for a long time who are in principle healthy, that you're able to see what happened before they actually developed some kind of event. And then you can look into the potential determinants of that event related to lifestyle and health status and history, and ideally, hopefully, also genomics, proteomics, metabolomics, and exposomics, and all kinds of biomarkers that might be related to the development of any disease. So one of the models that we've been developing in collaboration with a donor physician, actually, who's working in Sanquin blood bank, is a computational model to predict hemoglobin and ferritin levels, and this model was based on that FIND+ study that I've shown before, so where a group of new donors repeatedly had their ferritin and hemoglobin levels measured, and this computational model was actually based on physiological information to see how their hemoglobin and ferritin levels would probably develop. And as you can see, these models actually very accurately seem to predict the actually measured levels. And we could also use then this model to predict for donors when they start donating at what frequency they should be to not become iron deficient after repeated donations over a period of 2 years. So our next step also, next plans also with the biobank are to, of course, to look into genetic determinants of these different iron deficiency or iron development trajectories, I must say, mainly looking, of course, at common or known SNPs that are cross-sectionally related to different iron parameters, and then because we'll, of course, be able to measure it repeatedly within the blood bank, biobank, we will be able to see if this also predicts declining levels or potentially more stable measurements of both iron and red blood cell data. And ultimately, we aim to go into more personalized donor iron management policies, taking these different study results into models that actually help to distinguish different subtypes of donors that might be more capable or less capable of repeated donations, put them at certain donation intervals, whether or not iron supplementation if willing, and potentially also different measurement strategies to then hopefully get to more successful donations, less hemoglobin deferrals, and also less iron deficiency. So that's a way of optimizing our policies. So to quickly conclude, well, repeated donations clearly deplete iron stores in our donors, particularly in men, also because they start with these higher levels. And iron deficiency is very significantly associated with subsequent low hemoglobin. And ferritin-guided donation intervals do seem to prevent iron deficiency and low hemoglobin, but it does not seem to work very much for improving their health, at least not with the questionnaires that we used. And we're further doing research into more tailored donor iron management policies with iron supplementation, donation intervals, and measurement timing. With that, I want to thank you and all my colleagues working on all these different projects. And if you have any questions, feel free.
Katja, indeed for that, Katja, that you have done tremendous work. There's so much that we'll have to do to catch up to where you're at. Now, just very briefly, is there anybody with a question they'd like to ask just now? Yes, in black, please.
I could only hear a very... Oh, yes.
Sorry. Hi. No, it's working. Sorry. Just my question was about the choice of the iron supplementation regimen, given that there's now data for the last number of years showing that alternate day iron is both more efficacious and better tolerated. So, or maybe that relates to the time the study was planned. And then my other question was, and perhaps you've mentioned and I've missed it, was there any plan to look at, either the genetics associated with the hemochromatosis or celiac?
Yeah, so regarding the iron supplementation, if I understood you correctly, you want to know why we opted for the alternate day supplementation as an alternative. That's actually because studies have shown that after iron supplementation, your hepcidin levels will go up again, which then prevents taking up the iron from your food and also from the additional supplements that you take. So it might actually work better to take it every other day rather than on a daily basis. Sorry?
Sorry, my question was the opposite. Why was it given daily? Because alternate day is now standard.
All right, yeah, that's of course easier to adhere to, because then you don't have to really think about did I take it yesterday or not. So it's easier probably to adhere, and also a more common practice. So that's basically the standard.
Any other question?
Hi, I found your talk was really, really interesting, but I'm just wondering, the amount of data that you have there, have you ever looked into the usage of the reticulocyte hemoglobin equivalent as an alternative to using ferritin?
Sorry, I could not completely hear your question. If we looked into
reticulocyte hemoglobin. So
reticulocyte hemoglobin
yeah.
measurements. Yes,
yeah.
We're actually looking into that now. So that's also being measured in the Forte study, which is not completed yet, of course. Okay. So I don't have any results on that, unfortunately. Okay. And in the FINUM study, we only had the capillary hemoglobin measurements. So there we did not have the data, unfortunately.
All right, thanks.
Yeah.